just had a good 10 to 15 minutes of some on and off moderate to heavy graupel. There is more coming in, and right here is the fall streaks. You can actually see it right around here. And there's more coming in right now. There's a particularly heavy band coming in right around here. You can actually see some of the streaks, some of the fall streaks right around here. There's a particularly intense one right there. So what we're getting right now is kind of snow, but it's a precipitation type that is known as Graupel. In fact, if you translate Graupel from German, it's sleet. However, Graupel is, in the English definition, not sleet, but a convective form of snow. Sleet forms when a snowflake melts and then refreezes before it hits the ground because of cold air below. Graupel and hail form the same way, through convection. Graupel is basically the early formation of hail. Normally, when you get a cold air aloft thunderstorm, sometimes in the spring or summer months, you would get, like if the temperature is in the upper 50s, you might get like pea-sized hail or larger graupel. That is technically hail. That is small hail that's falling. Or large graupel. Graupel right now, like what we're getting is really small graupel. I mean, now we're also getting, now as the precipitation is less intense, we're also getting some snowflakes, but it's mostly graupel right now. Even when the precip is very light, it's graupel, because lake effect in its origin is convection. It's convective. It's caused by the warm lake, cold air temperature, so rising. It's caused by lapse rates. It's caused by steep lapse rates, so by rising particles of air. It's not formed through, say, just regular baroclinic processes. It's not formed by lake effect snow is not formed through regular processes such as a snowstorm would, like a coastal storm. That is why lake effect snow is almost entirely convective, because you have lake effect snow forms by the temperature difference between the higher elevations, the upper air, and the water temperature. So temperature difference between 850 millibars and water temperatures right off the lake or over the lake. For example, in order to get lake effect snow, it's not just a temperature difference, and you could have several ingredients come together, such as cold winds over the lake. You can have the steep lapse rates, but if you don't have a lot of moisture, you're not going to have a lot of lake effect snow. You'll just get a little bit, like what we're getting right now. But if the atmosphere is more moist, let's say you're getting some moisture right behind a cold front, or the winds are strong, very cold, and kind of moist, you would get a pretty intense lake effect snow event. Like the type of event that bring you 2 to 3 feet of snow. That's normally not the graupel that does that, but that's the more, because the band would then thicken. It would become really thick. It would become a really thick band of heavy snow. And maybe at the onset or the convective edges, you would get the graupel, while in the middle of the band, you would be getting all the heavy, white, fluffy snow. This band is very narrow. This is a very narrow band, and it's just in its infancy. As you're going further away from the lake, the band actually thickens out. It spreads out and becomes less convective. It's still producing graupel, so we're getting what is known as styrofoam snow right now. This is kind of like styrofoam, and the way it's pelting my jacket, it actually sounds like rain. Anyway, I'm probably just going to make this into a YouTube short, as no one is watching the live stream. Thank you for watching. Bye.